my name is Tim Littert. I'm the scientific project manager of Bots2ReC and working at Aachen University in the area of robotics.
Well, we are happy to see you here with your exposition, and I was just wondering if your robot is reconstructing or destructing the house.
It is actually deconstructing, or better to say it's doing a renovation job. So the idea is to remove asbestos material from private flats or office buildings. So as you might know, there still is a lot of asbestos contamination in Europe in different flats, and it's very tedious and dangerous to remove it manually. So the idea is to use a robot to remove this dangerous material from the flat before rebuilding or refurbishing the flat.
Okay, so at this moment your project is more or less taking care of asbestos.
Exactly.
And there's no human in the environment, or at least, or if so, he or she is protected.
Exactly. So the idea is, if you're removing asbestos, usually a worker operating in the room will need very heavy protection clothing.
Yes.
And so we're trying to get the worker out of this situation so he can be at the site and remote control the robot, distribute tasks to the robot, and have some remote control and feedback with the system. But he's not in the dangerous situation anymore, but the robot is doing the dangerous job to get the people out of this situation.
I remember until recently it was impossible to have a robot to guide a pneumatic hammer. Is this now possible with your robot?
It is what we are aiming for. A pneumatic hammer is in particular difficult because it's having this impact, and what we are using is a grinding tool. So it's a standard grinding tool like you would use on a construction site by manual operation, so it's proven technology. And we are trying to develop different methods to control this system, either by using a passive alignment with springs, which makes it a bit easier to control the robot in position, and on the other hand, to use a force control system with radar sensors that give us the feedback and the distance to the wall. But clearly this is one of the main challenges of the project, to get this running with a good operation. First tests have been successful, but there is a long way to go to make it operate very robust.
So there are many problems in control and physical structures and...
So one challenge you have to keep in mind, which was a big challenge when constructing this robot, is the size you need. So you need to reach up to 3 meters, and you need to be able to operate on the floor. On the same, you want the robot to be able to enter a flat, fit into an elevator to be able to get to the site. So it needs to be compact but with a long reach, which makes it necessary to construct a special robot and not use a robot out of shelf.
Now, what happens after work? Does the robot needs to be decontaminated?
In this case not. The idea is, we had a look at the whole workflow, how is the asbestos renovation normally done and where can we use the robot. And what we will do is we'll bring the robot in a box to the construction site. We can seal everything, then the robot starts operating, and the contaminated robot can get back to this box, which can be decontaminated easily.
Okay. And
then we're able to go to the next site. Of course, we're able to decontaminate it, not in this version, but in the later second prototype that will follow. If you need to do repair works or something like that, that's necessary. But for everyday operation, we can skip this.
So what is the size of this robot now? I mean, this is the model.
So this is a 1:10 scale model.
Okay.
And this is nearly full size. In fact, it's a little bit higher, so about 1.80 meters high, and can reach up to 3 meters. So it is about the size of at least long human, a bit bigger than a standard.
Now, is there also a visual control, like teleoperation?
Yes, indeed it is. So what we're having here, we're having, for example, cameras here at the system, and all the sensor feedback we have with the robot is feedback to a user interface where you can teleoperate the robot, you can see the task it has planned and is executing, and you can give some feedback to the process parameters or the control of the grinding process.
Does this include force control or force feedback?
No, this does not include haptic feedback to the user, at least not at this stage. The idea of teleoperation is to use the position control, which is intuitive, and leave the direct control on the wall to an autonomous system to make the operation.
And are companies in your consortium who are
Yes,
experts in this
mainly.
field?
So We have one big company, ERW2017 Construction from France, who are interested in the process of asbestos removal, and then Robotics is providing the platform. Daniele Taylor Robot Labs was building and constructing the arm, and we have an expert on sensor technology, Indirat from Aachen. So we're having a consortium of many industrial partners that are willing to bring this product to the market later as well.
What time range do you think? How many years will it take to become a product?
So we're on half of the project runtime now. We have 1.5 more years to go to get to working second prototype, and we expect to need 1 or 2 years of product development after the funded project to get to a product on the market. But we will finish with tests on a rehabilitation side, and then of course certification and last design steps need to be taken.
And now coming back to construction, I mean reconstruction, are you aiming at robots, then maybe doing something else after the asbestos has been taken off? So to use something which is less harmful?
So not particular in the project, but a lot of the technology and experience can be transferred to painting jobs or reapplying plasters. So it's a long-term idea to use our knowledge from the project for more applications in construction robotics.
I see. So is there anything you can transfer to other applications?
Yes.
For example, shipbuilding. I think this is a very tough job also in shipbuilding. Very heavy, or in...
Shipbuilding is very special. What makes it comparatively easy to use a robot in this situation is a clear environment. It's dangerous, so a lot of stuff is removed. So the environment is relatively structured for asbestos removal.
Okay.
And the next step would be to go to a bit more complex environment, for example, reapplying plaster or paint. But shipbuilding or normal construction sites still are a big challenge because they are so complex and complicated and changing every half day basically.
Okay, so I wish you good luck and thank you very much.
Thank you very much.
Very interesting.
It was a pleasure. Thank you.